students, welcome back to the channel. So in the previous video we had understood the definition of valency with respect to the number of hydrogen atom. So in the first example of HCl, the valency of chlorine, because the number of hydrogen atoms combining over here is 1. So the valency of chlorine with respect to the number of hydrogen atom becomes 1. In the second example, that is of water, the valency of oxygen is 2 because 2 hydrogen atoms are combining with oxygen. So the valency with respect to the number of hydrogen atoms here becomes 2. So the definition of valency is the number of hydrogen atoms which can combine with one atom of the element forming a compound. So in the example of ammonia, the valency of nitrogen will be how much? Now it's easy to explain. Count the number of hydrogen atoms here. The number of hydrogen atom is 3. So the valency of nitrogen in ammonia becomes 3. Now the very most important thing which we have to see here is the valency pattern in the periodic table. Now remember, for Icse you need to know only the first 20 elements of the periodic table. Now if we see group 1 elements, in group 1 we have hydrogen, lithium, sodium and potassium. So this is group 1. Group 2 we have beryllium, magnesium and calcium. Okay, so till here only we are seeing. And then moving on to group 13, we have boron and aluminium. 14 we have carbon and silicon. 15 we have nitrogen, phosphorus. Group 16 is oxygen and sulfur. 17 we have fluorine, chlorine, and the 18th group, that is also called as the noble gases or the inert gas elements, that is group 18, or we also call it as group 0, because here the valency will be 0 because their octets are complete, except for helium. Helium has 2 electrons. Neon, its configuration will be 2 8 and argon will be 2 8 8. So in the 3 noble gases we see that their octet is complete, hence they don't participate in any give and take of electron. That's why we say that their valency is complete and their valency will be represented as 0. Now if we see for hydrogen, lithium, sodium and potassium, the group number will tell the number of valence electron. So hydrogen, it has got 1 electron in its valence shell, it has only 1 shell, so its valency is 1. If we see lithium, its configuration is 2 1. So here the valence shell is telling, the valence shell is what? The outermost shell. The outermost shell is telling the valency of the elements. So likewise for sodium and potassium also the valency will be 1. Moving to beryllium and magnesium, beryllium configuration will be 2 and 2 because its atomic number is 4. So the valence shell is how much? 2. So its valency will correspond to the valence shell electron. So here the valency again becomes 2. Now boron and aluminium, boron configuration will be 2 and 3. So what will be the valency for boron? Now boron is a metalloid, its valency will be plus 3. Then moving on to carbon, carbon atomic number is 6, so its configuration will be 2 4. So what will be the valency of carbon over here? It will be 4. Then moving on to nitrogen, nitrogen atomic number is 7, so its configuration will be 2 and 5. Now here it requires how many electrons to complete its octet? It requires 3 electrons in order to complete its octet. So it will gain 3 electrons. So its valency here will become, nitrogen's valency will become minus 3. Then oxygen, it is 8. Now oxygen is 8, so its configuration will be 2 6. Here it requires how many electrons to complete its octet? 2. So here the valency becomes minus 2. And likewise for fluorine, the configuration will be 2 and 7, and here it requires 1 electron in order to complete its octet, so its valency becomes minus 1. So what is the pattern which we have seen over here for the first 20 elements? The pattern is something like this. Group 1 valency is 1, group 2 valency is 2, then group 3 and 4 again it is the same as the group number. Then when we move towards the group 5, group 5 is what? Group 5 is from nitrogen onwards. So from nitrogen onwards it becomes 3, 2, 1 and the noble gases, the valency becomes 0. So to find valency, first what you have to find? The number of electrons that are present in the valence shell or the outermost shell. The number of electrons that are present in the valence shell will correspond to its valency. Okay, so for group number 1 to 4, the valency remains the same, whereas when we move towards group 5, it changes to -3, -2, -1 and 0. So that is what you have to remember only for the first 20 elements. Okay. Next, what we are going to see, what is a chemical formula. First, see the definition. It is a representation of a substance by means of symbol. So, if we take the example of sodium chloride. Now, sodium chloride is a compound which is represented by symbol Na and Cl. So, what are the symbols over here? Na and Cl. Na is sodium and Cl is chlorine. And how many atoms are there? There are 1 atom of sodium and there is 1 atom of chlorine. So, when we see a given chemical formula, we can also see the number of atoms that are present. So, in a compound, when we are writing a chemical formula, it denotes the number of atoms of each element present. So, this concept becomes very important. If we take an example, so in the exam, if it comes, if a compound calcium sulfate is given, first list out the elements. Which elements are present? Calcium, sulfur and oxygen. 3 elements are present. And how many atoms are present? 1 atom of calcium, 1 atom of sulfur, and how many atoms of oxygen? 4 atoms of oxygen are present. So, these types of simple questions can be framed where you have to identify the number of elements and how many atoms are combining in that particular compound to form a given frame a given chemical formula. So, these chemical formula is very important, and earlier we had discussed the valency chart. Now, valency chart will play an important role while we are writing the chemical formula. So, whenever we are writing a chemical formula, you need to know the symbol and valency. These are the 2 most important aspects which you need to remember. So, if you have to write the formula of magnesium chloride, let's take this example of magnesium chloride. So, first of all, you should know what is the symbol of magnesium. It is Mg. What is its valency? 2 plus. And chloride is Cl. Its valency is 1 minus. So, how we write the formula? First, we write the symbol along with its valency. Then, we are going to interchange their valencies. When we are interchanging the valencies, we are going to ignore the positive and negative sign. So, magnesium gets the valency of chlorine, it is 1, and chlorine gets the valency of magnesium, it becomes 2. So, very important, we will ignore the positive and negative sign. So, once we have interchanged the number, what will be the formula? It will be MgCl2. So, that is how we write the chemical formula. Let's take few more examples. If we have to write the formula of zinc sulfide, IDE, important. Zinc, its symbol is Zn, its valency is 2 plus, sulfide is S2 minus. Again, interchanging, no difference it will make because both have a value of 2 and both 2 gets cancelled. So, the formula here becomes ZnS. This is zinc sulfide. Next, if we write iron 3 sulfate. Now, earlier we had discussed that there are certain elements which show variable valency, and iron shows a variable valency of 2 and 3. So, here the valency for iron given is 3. So, iron symbol is Fe and its valency is 3 plus, and sulfate, it is represented as SO4 2 minus. Again, interchange their valencies ignoring the plus and the negative sign. So, iron becomes 2, sulfate becomes 3. So, what will be the formula now? Fe2SO4, within brackets we place it and outside we place it as 3. So, the formula for iron 3 sulfate is Fe2SO4 whole thrice. Okay. Another example if we take, that is of ammonium carbonate. Ammonium carbonate. Now ammonium and ammonia, many times children make mistake. Ammonia is NH3 and ammonium is the only positive radical having a valency of +1. Carbonate is CO3 2 minus. Again interchange the valencies, ammonium becomes 2 and carbonate becomes 1. So what will be the formula of ammonium carbonate? It will be NH4, the whole within the brackets, and then outside we put 2 and carbonate is CO3. So that is the formula of ammonium carbonate. Okay, let's take few more examples. Now for this for writing the chemical formulas, children, you need to be well versed with the valency chart. If you don't know the valency chart, then for you to write the chemical formulas will be very difficult. If I ask you to write the formula of calcium sulfate, now calcium, you know, its valency is 2 plus and sulfate is again SO4 2 minus. Again both have the same valencies. Interchanging we get 2 and ignoring the plus and minus sign, the formula becomes CaSO4. Okay, let me take a little typical one. If we have to write potassium zincate, potassium zincate. Now potassium is K1 plus and what is zincate? Zincate is a new, you can say, radical for you to learn. It is ZnO2 2 minus. Interchange their valencies, potassium gets 2, zincate gets 1. So the formula is K2ZnO2. I hope you are following how you have to write the chemical formulas. For variable valencies, if you get the example of copper 1 chloride, copper 1 chloride, it means its valency is specified. Copper valency is 1 plus, chloride is 1 minus. Again interchanging, there will be no difference, 1 and 1 get cancelled. So the formula will be CuCl. Okay, so keep on practicing. The more you practice every day, you will become well versed with writing the chemical formulas. And before you start practicing, please remember, learn the valency chart. It is very important. Okay, let me take few more examples. If I have to write sodium bicarbonate, sodium bicarbonate. Now sodium, you know, its valency is Na1 plus, bicarbonate is HCO3 1 minus. Interchanging, both are 1 and once 1 is there, we ignore these values and the formula becomes NaHCO3, that is sodium bicarbonate. Okay, if you have to write calcium nitride, now before I write, you try to quickly write the formula of calcium nitride. Calcium is Ca2 plus and nitride will be N3 minus. Okay, so what will be the formula? Interchanging the values, the formula becomes Ca3N2, calcium nitride. Okay, so learn the valency chart, then only start writing the chemical formulas. Okay, now we are going to list out some important chemical formulas. These are very simple formulas, but children make lot of mistakes for these simple formulas also. Let's see few gases. Now whenever you are asked to write the formula, molecular formula of oxygen, it is O2. It is never O. O means you are talking about one atom of oxygen. So never write it as O. If you are being asked to write the formula of oxygen gas, it will always be O2. Likewise for hydrogen gas, it will be H2. Nitrogen gas will be N2. Never write N. For hydrogen gas, don't write H. Okay. Hydrogen chloride gas is HCl. Okay. And ammonia gas is NH3. Again, don't write ammonium ion. There is a difference between ammonium ion and ammonia. Okay, ammonium is a radical and ammonia is a gas. Other gases are carbon monoxide, both should be capital letters. If you write a small letter, it becomes a different thing. It becomes an element of cobalt. So never make these mistakes. When you are writing carbon monoxide, both the letters should be capital letters. Carbon dioxide is CO2. Nitrogen monoxide, mono means one oxygen atom, that is nitrogen monoxide. The other name for it is nitric oxide. Okay, nitrogen monoxide or nitric oxide. Then we have nitrogen dioxide, that is simple to remember. Then one more gas is there, that is dinitrogen oxide. Dinitrogen means two nitrogen atoms. Dinitrogen oxide also called as nitrous oxide. So these can be easily framed for your MCQ, where many children make mistakes. They get confused between nitric oxide and nitrous oxide. So nitric oxide is, you remember, it is nitrogen monoxide, and dinitrogen oxide is nitrous oxide. Now we have few important acids also. Hydrochloric acid is HCl, nitric acid is HNO3. Now some children thinking that it starts with letter N, they start writing some formula with the letter N. That will be wrong. You have to remember nitric acid is HNO3. Likewise for sulfuric acid, it is H2SO4. Don't start writing the formula with some letter S. Okay, sulfuric acid is H2SO4. Carbonic acid is H2CO3 and phosphoric acid is H3PO4. So all these are important acids which you need to remember. Few bases we list out. KOH is potassium hydroxide, NaOH is sodium hydroxide, and calcium hydroxide is CaOH whole twice. These are some bases. Then we'll also list out few salts. Salts, we have copper sulfate, we have sodium chloride, and we have potassium nitrate, KNO3. These are few salts. Okay, so all the formulas are important, and if we have to write certain metallic oxide, calcium oxide is CaO, iron 2 oxide will be FeO, iron 2 oxide. How I got FeO? Again frame the formula, iron valency 2 plus is given, oxide is 2 minus, interchanging, 2 gets cancelled, so the formula becomes FeO. Okay, so these are the some important chemical formulas which you need to remember, because these can be asked in your examination. So I hope you have followed and understood how to write a chemical formula. The valency chart is important. Please learn it. In the next video, we will be talking about how to balance a chemical equation and what are some of the important facts you need to understand when we are talking about chemical equations. Thank you, students.